Now that you understand how to convert between exponential and logarithmic form, we're going to use that to simplify logarithmic or exponential expressions. The way we're going to simplify logarithmic or exponential expressions is by trying to change forms. So for example, if I'm given a logarithmic expression, I'll try to turn that into exponential. If I'm given an exponential equation or exponential expression, I'll try to change that to logarithmic. So looking at my first example here, I have log base 2 of 2. If I want to try to simplify that, first thing I'm going to tell myself is it's got to be equal to something. Let's say it's equal to some unknown value. Call it y, because then it's in a familiar form for us. If I now try to change that to exponential form, since this is a logarithm, I'd have 2 to the y equals 2. Well, what does my y have to be? Or in other words, what does log base 2 of 2 have to simplify to be? Well, in order for 2 to the something to equal 2, that something, that exponent, has to be 1. Therefore, log base 2 of 2 is equal to 1. Looking at letter B, I'm going to do the same thing. I'm going to say this logarithmic expression has to be equal to something. Let's call it y. Then changing to exponential form, I'll have 3 to the y equals 0. And I'm going to ask myself, what exponent would make my expression 0? Well, nothing would, because if you think of what does an exponential function look like, remember, it's only values that are greater than 0. It never actually touches 0. It has that, that horizontal asymptote. So I'm going to go ahead and say that there is no solution to this expression. So therefore, I could not simplify log base, well, no, I take that back. I can simplify it by saying log base 3 of 0 equals no solution. Looking at example C. Now, this one's a little bit tricky. Most people will say, hey, I see a log in it, therefore it's in logarithmic form. However, notice that this is 4 raised to the exponent of log base 4 of 7. I know it looks a little funky. It's hard in this program to do, or any program for that matter, to do a subscript that's in an exponent. So I do apologize for that. But once again, this is 4 raised to the log base 4 of 7. So this is exponential form. I'm going to say this exponential function is equal to some unknowns, call it y. And I'm going to change to log form. I'm going to say that log, I keep my base 4 of y equals my exponent, which is log base 4 of 7. Well, in order for the left side and the right side to be equal, notice that this y has to be a 7. So I'm going to go ahead and say that 4 to the log base 4 of 7 is equal to just 7. And it should make sense that when I'm taking a function and its inverse function, putting them together, I am left with just that variable value, as we looked at before when we looked at inverses. Looking at the next example, letter D, I'm in a logarithmic form. I'm going to say this logarithmic form is equal to something. So I'm going to go ahead and change it to exponential form and say 6 to the y equals 1. Well, because I know that anything raised to the 0 power is 1, if I remember that fact from Algebra 1, that a to the 0 is always 1, I'm going to go ahead and say log base 6 of 1 is just 0. Looking at example E, again, I have a logarithmic equation. I'm going to set it equal to y, and I'm going to say 4 to the y equals 256. So from here, I might use my calculator a little bit to help me. I don't have a calculator here with me while I'm recording this video, so I'm going to take a couple extra steps. I know that 256 is 16 squared. Therefore, 16 is 4 squared, so I know that 4 to the y equals 4 squared squared. So 4 to the y equals 4 to the 4. Therefore, I can now take the jump and say that that must mean that log base 4 of 256 is equal to 4 in order for my left side and my right side of my equation to be the same. Notice that if I had had a calculator, I could have just said, well, I know 4 squared is 16. I could have said, what's 4 cubed, what's 4 to the 4th, and I would have seen that when I put 4 to the 4th into my calculator, I did get 256. But going back to my original problem here, log base 4 of 256 must be equal to 4 in order for my exponents to be equivalent in these two equations. Looking at letter F, doing the same thing, I'm going to say, hey, this is equal to some y. Therefore, 2 to the y equals 1 over 32. Well, I could say that 32 is the same thing as 2 to the 5th, because in order for me to be able to figure out what y is, I'm going to have base 2 over here as well. I don't quite have base 2 yet, but I'm involved with a base 2, so what if I move this to the top? Then I could say 2 to the y equals 2 to the negative 5, and therefore y has to equal negative 5. And log base 2 of 1/32 is equal to negative 5. My negative 5 is a little sloppy there. It almost looks like an equal 5 up there. Looking at just a couple more, notice that now I'm involving some log-based tens and some natural logarithms, or in other words, ln's. So again, I'm going to set this equal to y. I notice I'm in exponential form, so I'm going to change to logarithmic form, because again, even though a log is involved, it's involved in my exponent. So I'm going to say log base 10 of y equals log of 4. Well, remember, log base 10 is the same thing as just saying log. So log y equals log 4. So in order for left side to be right side, y has to be 4. Therefore, 10 to the log of 4 equals 4. Looking at letter h, again, going to set it equal to something. So my natural logarithm of e to the 4/5 equals something, call it y. And remember, ln is the same thing as log base e. And changing to now to exponential form, I would take my base e to the y equals e to the 4/5. Therefore, my y has to be 4/5 in order for my left side to equal my right side. And I can say ln of e to the 4/5 is equal to just 4/5. Looking at my last two examples, again, I notice that this is equal to some value, call it y. So log is the same thing as log base 10. And so I have 10 to the y equals 0.01. Well, notice that this is a form of scientific notation. Isn't this the same thing as saying y times 10 to the y equals 0.01? Well, so I need to have an exponent that's going to make me move my decimal 3 places to the left. No, 2 places to the left, because I have only 1 0. So I need to move my decimal 2 places to the left, so I'm going to say that y must be negative 2. Because 1 times 10 to the negative 2 is 0.01. Therefore, log of 0.01 equals negative 2. And finally, the last one to simplify, going through the same process, changing to exponential form, e to the y equals 4. So looking here, I notice that I don't know e to the what equals 4. I have no idea. This for me is not solvable, even though I changed to exponential form. But I do notice that ln is something that I can find on my calculator. So remember when I mentioned before when I told you about these two special values, log base 10 and log base e, that those are the only two that you find on a calculator. So since changing to exponential form did not help me, I'm going to assume that this does not solve to be a nice rational number. So I'm going to go ahead and go to my calculator and put in ln of 4, and I get, and my calculator tells me that that is approximately, I'm going to use my approximately symbol, 1.386. And I will always go to 3 decimal places if I'm not told how far to round. So that's how you're going to use converting between log and exponential form to help you simplify logarithmic expressions.